All right, team, it's recording. Here we go. Exercise 7D. What you're learning from 7D is just simply learning how to read function notation. Here's an example. Log e of x plus log e of y is equal to log e of xy. That's one of the log rules. And same thing with the other log rule. If you subtract the two logs with the same base, then it is the same as dividing them. Now let's rewrite that as a function notation. So for example, and when you use function notation, you'd use let, and then you tell them what you want. Yeah. So let f of x, I'm using f of x as my function notation, to equal to log e of x. So I'm going to replace this log e of x with f of x. How would I replace log e of y then? Can I please have Joe? F of y. And similarly then, log e of xy, all I'm really doing is I'm just replacing the x with xy, so that's why it's f of xy. What you see here is exactly the same interpretation as the above line. The only difference is one is in function notation, and the other one is what you actually read it as. Yeah? Then that means if I did keep it as f of x is equal to log e of x, that would mean log e of x is f of x. Take away log e of y, which is f of y. What would that equal to? Can I please have Serena? Beautiful. So far, so good? Now, I believe in the notes you guys have a bit of a typo that I fixed for myself. Can you double check if that's correct? Is that times on yours or is it plus? Okay, can you change that to times, please? There should be a times there. So we know with indices, index laws, e to the x plus y is the same thing as e to the x times e to the y. Function notation. If I said let f of x equal to e to the x, then that means e to the x, which is here, that's f of x times f of y. Then how do I rewrite e to the x plus y, Samuel? Yes, which is over here, but I want to write it in function notation. So function notation, you can see that e to the x becomes f of x, e to the y becomes f of y. So my question is, what is e to the x plus y? How would you write that as a function notation?
To the x plus y.
But not to the, it's just f of x plus y. Okay, because what we can see here is wherever the x is, I'm just replacing the x in the exponential. So if that's x, that's x. If this is y, this is y. And what do you want? You want x plus y in the power component. So all you have to replace is x plus y. You get your x plus y. That's what exercise 7D is. Okay, so it's more of a language, getting used to reading what the notation means. That's all it is. Familiarize yourself with that because examiners are more likely to give you this than this. Okay, so function notation, they're likely to give it that form. They'll write it with the domain, and you need to be comfortable reading that notation. That's what exercise 7D is. So what do you take out of it? It's not about doing all the questions. It's about, if I had to do this question, do I know what it's asking me to do? That's what you're trying to learn. Yeah? So let's do an example. Oh, sorry, I haven't done this one. So let's just fill this one in. Oh, you guys can fill this one in. I left it blank for both sides because I wanted you to do it. Let's go. Alex. What would this be?
Let f of x minus y.
Beautiful. Is equal to?
F of x over y.
Beautiful. Now let's do an example. Here's an example where they use function notation. Example 1. They say, find the possible rules for g of x. Because g of x has to equal to something. So there must be more than one, because hence possible. Given that g of x squared plus x times g of x is equal to 6x squared. Looks crazy, but if it helps, you could replace it with a letter if you want. You could say, let g of x equal to a, if you wanted to. Might make it easier. So then it would change this to a squared plus x times a is equal to 6x squared. Solve for a. Okay, so that might be easier. If you prefer that, then make sure to use let. Okay, if you're doing that in the exam. Okay, so if you're introducing a new variable, like for example with inverse functions, instead of writing f inverse all the time, you can say let f inverse equal to y and then proceed with the letter y. Okay, then that's okay. If you don't do that, they penalize you. Here we go. So if I did this, now how do I solve for a? What am I going to do? Because I just replaced all of this with an a. I just replaced it a. You're trying to solve for a. What are we going to do? Anyone have clues on what they would do? Alex.
Guess would be make it to quadratic.
Ooh, how would I make it into a quadratic? That's a good guess.
Let 6x squared to the other side. In other words, like a squared and then 1a.
It's not too bad. It's a good start. What are we going to do now? Noah? All right, so we use quadratic formula. What is my A, B, and C if we did use quadratic formula? Which one? So which one's C, which one's B, which one's...
A would be 1.
A would be 1. So coefficient of A squared, yep.
Yeah, A would be x. And then C would be negative 6x squared.
That works. We could do that. Then using quadratic formula, you would get A is equal to, rather than X. Does that not work? So if you kind of think of it as like usually you have X squared plus X and then there's a C. So what Noah's done is he's saying that think of A as your X. So coefficient of X squared is 1. Coefficient of X is A, but he's swapping it around. So hence it becomes X there. And then your last term is minus 6x squared. Yeah, so that works. So far, not wrong. So then that means instead of x equals 2, it'll be a equals 2, and you can have negative b plus minus square root b squared minus 4ac all over 2a. What would you get? You would get, according to your method here, you would have negative b plus minus the square root of b squared, which is x squared. What is this? Minus 4 times 1 times c divided by 2 times 1, which is 2. Not too bad. Negative x plus minus square root of x squared plus 24. X squared, is that right? Yeah, that looks right. Over 2, but then x squared plus 24. X squared is the same thing as writing plus minus root of 25x squared. What do we do now? Because we can square root the 25 and we can square root the x squared. So negative x plus minus 5x on 2. That means a, which is, remember that's g of x, could equal to what? What are my two possibilities? Very good. So negative x plus 5x is 4x on 2. Or a could equal to negative x minus 5x is minus 6x on 2, which works out to be 2x or negative 3x. So far, so good? Yeah, I guess that is probably the approach. I was thinking something else, but I guess it works too. Yeah, that's what I was going to do. Yeah. Yeah. I was going to, but I also know because it's a not equal to 0, so you did have to bring it across. And then I would have done, I was going to do either completing the square or take out a factor of a, but actually no, completing the square might have been the other way. Yeah. But this one is quite plug and play, so it's not bad. Come up with your own solution, however way you want, as long as you get something. Let's try the next one. Flip over to the next page. I'm going to pause the video. Oh, sorry, don't leave your answer like that too. Make sure to return back to the g of x.
So when you solve for x, you solve the possible.
Yeah, because it just says find the possible rules. So we just wanted a rule for g of x. Yeah. All right. I'm going to pause the video for this part. I want you to see if you can solve this one now. Same idea. Same practice. Last example of 7D. Example 3. So for the function, function f of x is equal to 1 on x squared, show that f of x plus f of y will end up being x squared plus y squared times f of xy. I've already gave you sort of a layout to set up how would you start this show that question. Because you can see that in the question there's an f of x, f of y, and there's an f of xy. Normally what I would do first is I find out what does that equal to. What is that? Since I know f of x is 1 on x squared already. So f of x is 1 on x squared, I fill that in. Then what would f of y be? What's f of y? 1 on y squared. Very good. Then what is f of xy? Just reading function notation. Very good. So this is 1 on xy squared, but exactly like what Joe said, this is the same thing as writing 1 on x squared, y squared. Okay, so now I've got my tools. Then let's start proving it. They want us to prove that f of x plus f of y, we need to simplify this. So let's write it out. That's 1 on x squared plus 1 on y squared. We've got fractions. To add fractions, you need to make sure same denominators. You can use cross method. Here we go, cross method. That will give you y squared plus x squared all over x squared, y squared. And that should be a hint already. See in the denominator x squared, y squared, I can already see it's over here. I've got that for f of xy. So maybe my next line, I can take it out. I split up the fraction. I can write it as 1 on x squared, y squared, multiplied to y squared plus x squared. True? Because that's, if I just split out the fraction, if I times it, denominator goes denominator, numerator goes numerator. Well, why do I do it like this? Because it's very familiar to what I have up there. I have 1 on x squared, y squared as f of xy. So this here can be replaced with f of xy times, and well, the addition, it's commutative, so it means that the order doesn't matter. You can write it x squared plus y squared, and hence proving that. If you weren't sure, another way is that you could have subbed this in just so you have a goal of where you want to reach to. So if you didn't know where to start, you could have started off something like this, and f of xy would have been times 1 on x squared, y squared, and then you would have got x squared plus y squared on x squared times y squared, and that would have gave you a hint of where to start. Okay, but never do this and then just say, yep, that's my answer. Use it as your way to figure out where you want to get to, and then you start from here. Because they're asking you to show this equals that. Start from there and try to get to what you want to. That's the hints. Okay, so that's 7D. 7D is just working on that. So if you feel pretty comfortable with that, pick a few and then move on. If you're not comfortable with reading the notation, then that's where you pick a few more to practice. Cool? All right. And the last exercise for chapter 7 is 7E, which is relatively easier. Just tie it all together, family of curves. You've got a lot of parameters to work with. Here we go. Flip over the next page. 7E. Family of functions is a set of algebraic equations with one or more parameters. In case you don't know what a parameter is, actually, any hands up, what's a parameter? not the restriction, but sometimes it can make the restriction. That's true. What's a parameter? We know variables. So if I ask you, what are the variables here? You would say the x. That's my variable, and usually you'd say y, x and y, right? So these are my variables. I'm highlighting in yellow. So what's parameter then?
The other stuff.
The other. M is a parameter. A is a parameter. A is a parameter. K is a parameter. E is Euler's number, right? Parameters are constant for a specific case, but you can change them. Variable changes in every single case. Okay, so here's an example. If I told you if m equals 2, then you will have f of x equals to 2x. Listening? Thanks, team. F of x equals 2x. Now this is fixed. You only have a gradient of 2. That doesn't change. But your variables can change. Your variables, your x can change and your y will change simultaneously, but your 2 doesn't. So it stays constant in that one specific scenario. Yeah? So parameters is what you're looking at today. Exercise 7E is, well, I don't give you 2 because that's specific. What if I gave you a letter like M? Then you have to explore all the possibilities. It could have been 2x, could have been 3x, could have been negative 2x, depending what the restrictions are on M. Okay, so that's why a parameter gives you a family of functions, because there's so many possibilities of what M could possibly be, but it's constant for each specific scenario. Okay, so let's have a look at this example. Consider the family of quadratics. So the first thing they tell you, you got quadratics, boys. With rules of the form, here we go, we've got x squared minus bx. That's a quadratic form. Where b is a non-zero real number. So they're saying that b can be any number except 0. Find x-axis intercepts. So let's start off with that. Y is equal to x squared minus bx. How do I find the x-axis intercepts? What's the first thing you have to do? Let's go with, who haven't I picked for a bit? Ryan. Let y equal to 0. To find x-intercept, you let y equal to 0. So now you have 0 is equal to x squared minus bx. My goal is to solve for x. So what's the next step? Can I please have Tara? What would you do? Factorize. You got it equals to 0, should be a hint to try to factorize and use null factor law. X bracket x minus b. This tells me that x must equal to what? Can I please have Charlotte?
0.
So far, so good? Yep.
Do you have to write like y equals 0?
I normally do, especially when you get to derivatives. If you just let something equal to 0 without saying, stationary points occur when derivative dy dx equals 0, they do penalize you there. So if you went from that line to a derivative equation with 0, they do. So out of habits, I usually do that, just in case they penalize me. So it's just part of my writing now that I just spell out everything I do, especially when it comes to inverses as well. I make sure I say let y equal to f inverse, define inverse, f of y equals x, and then I do it. I don't just jump in and swap in the x and y's. So it's just more for exams. When you're doing it normally, it doesn't matter, but in exams, it does. Yeah. All right, B. Find the coordinates of the vertex of the parabola. What's a vertex of parabola really asking? Turning point. So you've got currently y equals x squared minus bx. How do I find the coordinates? Notice the word is coordinate, so you need x and y. You need the x and y coordinate. How do I find the turning point? Yes. So turning point, there's a lot of things that you've learnt from quadratics. You know that a turning point has an x and a y coordinate. You can find x coordinate using axis symmetry rule. And the one that Mia just said was negative b on 2a. That's another way to do it too. Or you can complete the square. Or you can take the two x-axis intercepts divided by 2. Okay, find the average, cut it in 2. And that gives you the average between it and that you find the x-coordinate. Many ways to do it, yeah? But let's follow this rule, negative b on 2a. So that would mean I would have the x-coordinate as, what's that, negative of negative b over 2 times 1, which is 2. So really you got b on 2, which makes sense because it's halfway between 0 and b. So it must be b on 2. That's true. Fair call. How do I get the y-coordinate then? Beautiful. Sub it back in to find your y-coordinate. So your y-coordinate is equal to b on 2 squared minus b times b on 2. That gives you b squared on 4. Take away b squared on 2. Let's do a bit of fractions. Who's comfortable with doing their fractions here? What's b squared on 4 minus b squared on 2? Alex? That is correct. It's like saying a quarter, take away a half. So it's negative half. All right? So therefore, my coordinates must be b on 2 to negative b squared on 4. Scroll down a bit. Next question, CI. Find the coordinates of the points of intersection of the graph of y equals x squared minus bx, so that's the quadratic, and the line y equals negative x in terms of b. Again, notice it said coordinates. So you need an x and a y. It says of points of intersection, so there might be more than one. How do I solve this? What's the first step you're going to do? Let's go with Ella. What would you do? Very good. X squared minus bx, the quadratic, to equate it with the line. That's our first step. X squared minus bx equals negative x. What are you going to do next now? Let's go with Ian. What would you do next? So then you have x squared minus bx plus x is equal to 0. Cool. What do we do now? Which one are you factorizing? And how would you do that? You could, maybe you can. Oh, no, there's that extra x here, so you can't. DOPS needs it to be a x squared minus a constant. Good. First thing is, when I see a lot of x here, I see where I can factorize first. And one of the things is, they're both x's. One's 1x and the other one's negative bx. So I would start off by doing this. Take out the x as a outside the brackets. What's inside the brackets? B. Or you could do like this if you want. So negative b plus the 1. You see that? So x times negative b is negative bx. X times 1 is positive x. Now, why did I do that? Is because this is my x squared, so the coefficient, which is a equals 1. This one is b, and then c is clearly 0. But still, I'm trying to solve for x and y. What are you going to do now?
I just did the same before. I just took an x from everything and then made it so like x on the outside and x minus b minus, or x minus b plus 1. So we're trying to solve for b. Make either equal 0.
Right, what are we solving for? We're solving for in terms of b. We're trying to solve for x in terms of b. So your goal is to find what x equals to. This is your goal.
You can subtract the second term from both sides.
Second term from both sides? What do you mean by that? Like
x squared is equal to, and then divide both sides. And then
I was just gonna. It's a good idea. You know what's confusing here for a lot of students that they may not see? Had I given you something like this, x squared minus 3x, and I asked you, how would you solve for x? A lot of you would have noticed here, you would have told me factorize. You would have said take out x as a common factor, use null factor law. True? That's what you would have done. But just because I don't have a number makes it a bit more complicated. Still the same thing. X squared plus, there's a number in front of x, but they both have a common factor of x. So what do? Take out x as your common factor, and then that becomes x plus negative b plus 1, or pretty much just minus b plus 1. You could.
Okay, cool.
I just thought this way it looks a bit more obvious, but yes, when I see x's, I take them all out. But yes, so now what are my x equal to? X can either equal to 0. Where's my thing again? So x could equal to 0, or x can equal to b take away 1. So far, so good? All right. This is exercise 7E. So if you found this a bit interesting or a bit tricky to think about, that's what 7E is trying to do for you, getting you to think with parameters. Yeah? All right, last question. Last 2 questions. Oh, damn. Oh, that's actually not too bad. Because point of intersection, they have 2. There's the quadratic and there has the linear. It's easier to do the linear. So y equals negative x, I would have subbed it in here. So for x equal to 0, then y would have been 0. And the second coordinate when x is b minus 1, well then it'll be the negative of that. So negative b plus 1. There we go. That's a quicker way. Thanks for reminding me it's a coordinate. Forgot about that. Last question, last 2. It says, for what values of b is there one intersection? Now, when you hear that or when you read that, what's the thing that you should be thinking of? 1 intersection, 2 intersections should imply discriminant. You should be doing discriminant at this point. So you should be thinking discriminant equals b squared minus 4ac. If you want 1 intersection, discriminant should equal to 0. So you need 0 is equal to b squared. Well, this is where it's useful to do what I did over here. So the b squared, that would have been negative b plus 1 squared minus 4 times a times c. Conveniently c is 0. What is b equal to? Can we figure it out from there? What's b equal to? 1. Because that's your factor. So 1 minus b needs to equal to 0. The only way that would happen is b is 1. But then the second question is, what if you want more than 1? So 2 intersection points. That means discriminant must be greater than 0. So how would you do this then? You need, cry. You need 1 minus b squared to be greater than 0. How do we do that question? Shh, 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 shh. Thanks, boys. Let's not speak while I'm speaking. Last example. How do you solve for that? 1 minus b squared greater than 0. What would you do? This is what I taught to my year 11s just recently. Draw the graph. Discriminant graph by b. A 1 minus b just means moves to the right by 1, and it's a negative graph, so it just looks like this. Oh no, it's not a negative graph, sorry. It's a reflection in the y-axis, is just the same shape. Moves across by 1, which makes sense. Why? B equals 1 for one solution, but if you want more than one solution, what must be b? B can be all real numbers, so any number on the left or the right, except for 1. That's the only way that you're going to have two solutions, because it's always going to be, the discriminant's always greater than 0. So far, so good? Because the next question is very similar but harder. So if you want to push your limits, have a look at the next one. This is question 12 of your textbook. You can refer to the solutions. But I'm going to stop there. That's it for today. That's 7D, 7E. You've got about half an hour of your time now. I'm going to stop the video here. And that concludes chapter 17. Next week, we're getting to derivatives, calculus, differentiation. Woo! I know. Pat will be all. He can get up here and teach you guys.
I have no idea how to sign up derivatives, guys.
Wait,